Hello, today I would like to introduce to the physiology of speech. After learning the lesson, you may be able to name the four components of the vocal apparatus, present and explain the mechanism of speech, and present the roles of nervous system in speech. The content of our lesson today include the introduction, mechanism of speech, role of nervous system in speech. About the introduction. The sound that we hear is coming from a vibrating object, emitted in the form of sound waves and travel through the air. For example, the strings or drum surface vibrate when plucking or tapping. That emits sound at the sound wave and spread into the air. It also needs a sound transmission medium like the air, water, or solid. In human, the speech itself is air that moves from the lung through the series of anatomical structures to the mouth, and sound waves are generated and molded into the intelligible speech. All languages are spoken by the same mechanism, although the words are different and require different anatomical structures. Before learning about the mechanism of speech, we will recall about the vocal apparatus. The vocal apparatus includes the respiratory organs, produce the vocal energies. The vocal cord produce the sound cells. The sound resonant cavities like the pharynx, oral cavities, and nasal cavity. The vocal organs include the lips, teeth, tongue, palate, and jaw, which mouth the sound. When we speak, the muscles of the abdomen and the chest contract, the diaphragm is lifted, and the air flow the lung is pushed into the trachea to the larynx and produce the vocal energy, or is also called the vapor. In humans, the vocal cords, also known as the vocal folds, are the folds of throat tissues that are the key in the creating sounds through vocalization. The vocal folds are located within the larynx, and they are the part of the glottis. The initiation of sound production begins in the larynx thanks to the two vocal cords, which are called the vocal folds. And the vocal cords is the combination between muscles and ligaments attached to the larynx at the anterior to the thyroid cartilage, which are fixed, and the posterior to arytenoid cartilage, located above the cricoid cartilage, which are mobile. The movable anter-arytenoid cartilage can make the vocal cord regulate the air flow in and out of larynx through the variable opening of glottis. When only breathing, it means not speaking, the vocal cord relaxes and opens so that the air flows through larynx, trachea, and lungs. But when speaking, the arytenoid cartilage come together so that the vocal cord closed, partially close the glottis, obstructing the airflow from the lung up. The air below the vocal cords is compressed, then separate them starting from the lower edge to upper edge. After reduce the air pressures to the negative pressure, two vocal cords shock in with its elasticity and close two vocal cords. This sequence is repeated during the speech, creating a vibration of vocal cords to emit the sounds. After that, the sound moves to sound resonant cavity, which are above the vocal cords, include the pharynx, oral, and nasal cavity. this area about 17 centimeters long in men and shorter in women, through which the sound moves on its way to the mouth and form a set of cavities where the sound is resonant. That energy is changed, increase or decrease, make the sound a resonance and full. The sound will be pushed to vocal organs. The vocal units in the mouth are with actions of the lips, teeth, tongue, lower jaw, hard palate, and soft palate. Once the sound leaves the vocal cords, it is shaped into words by other structures, which are called the vocal organs. These are the movable structures, such as the tongue and lips, that can be configured to form a given sound. The mouth is the final mechanism by which sound is tailored into words. The soft palate at the back of the mouth, the hard and bony palate in the front, the teeth, the tongue, and the lips come into play during speech. The nose also provides an alternate means of issuing sound and is the part of production of the speech. The movement at entire jaw can alter the size of the mouth cavern and influence the tone and volume of the speech. When the back of tongue is raised to touch the soft palate, it can create the sound K and G. It's K, G. And when the lips come to touch with each other, we can create the sound M, B, and P. And when the lower lip touches the upper incisors egg, we can create the sound F and V. If the tip of tongue makes contact with the palate just behind the incisors, we can create the sound D. In case the upper and lower incisor eggs come close to each other but do not touch, the air passes between the teeth and sound S. When the tongue touches the upper incisors, we can create the sound th. The speech is made by pushing air up from the lungs, and it occurs during expiration. Then we have to inhale quite quickly at the end of the sentence or at the pause. An extended inhalation allows a wide range of words and phrases to be uttered. About the occlusion and speech, the two contacts do not take place during speech. Speech is a complex series of events that takes place with little or no conscious control from the speaker other than selection of the words to be spoken and the tone and volume at which to deliver them. The speech center in the brain coordinates movement of the anatomic structures to make the selected word become reality. Speech is a very complex activity, involving a high degree of coordination between respiratory organs, the larynx, and the vocal organs. The several cortex and associated subcortical structures integrate auditory, somatosensory information to dictate the appropriate muscle coordination in order to make the fluent and intelligible speech. The nervous system regulates the vocal system on both levels, consciously and unconsciously. For example, when you want to sing, you can consciously move your lips to create different consonants and vowel sounds, and so that the brain controls non-consciously the coordination of muscles that allow the lungs provide the required amount of air. The vocal cords vibrate to produce the short sounds, and the movement of vocal organs. Speech disorders can result from defects in peripheral speech apparatus, like in case of weakness, paralysis of organs related to speech functions such as lips, tongue, larynx, articulatory, slurred speech, interrupted speech. And in the central speech apparatus, when the area of brain that controls language is damaged, so that it can cause the language dysfunctions. And the people who suffer from this case will be difficulty speaking, and slurred speech or poor communication. And in the case of cerebral stroke or brain injury, brain tumor, people can suffer from this. So after learning this lesson, you may able to know how speech is created. And in summary, in order to make the speech, the air flow from the lungs will transmit to the vocal cord and make the vocal cord vibrate to create the source sounds. This is the sound waves with different frequencies through the amplifying transmitter at the resonance cavities combined with the vocal organ in order to make the intelligible speech. That's all for our lesson today. Thank you and see you next time.